We now discuss the solution of a problem from the section Quadratic Equations and Complex Numbers, and the problem is related to complex numbers. This question has appeared in the joint entrance examination main held on 29th June 2022 in the first shift. The given question is, let S be the set consisting of all those complex numbers Z such that modulus of Z minus 2 less than or equal to 1 and Z into 1 plus I plus Z bar into 1 minus I is less than or equal to 2. Let mod of Z minus 4I attains minimum and maximum values respectively at Z1 belongs to S and Z2 belongs to S. If 5 times in brackets mod Z1 square plus mod Z2 square bracket close is equal to alpha plus beta root 5, where alpha and beta are integers, then the value of alpha plus beta is equal to. It's a numerical type question. We are given a set S, which consisting of all those complex numbers Z, which satisfy mod Z minus 2 less than or equal to 1 and Z multiplied by 1 plus I plus Z bar multiplied by 1 minus I less than or equal to 2. And it is given modulus of Z minus 4I, that means 4I attains minimum and maximum values respectively at points Z1 belongs to S and Z2 belongs to S. That means the distance between a point Z belongs to S and the fixed point 4I, modulus of that, and for various values of Z belongs to S, we have to think of the minimum and maximum values of modulus of Z minus 4I for points Z1 and Z2 belongs to S. And if you get Z1 and Z2, then it is given to you 5 times mod of Z1 square plus mod of Z2 square is equal to alpha plus beta root 5, where alpha and beta are integers, required to find the value of alpha plus beta. We now discuss the solution of the problem in detail. We have the set S given like this. And in this, the complex numbers that are in S must satisfy these two equations. The first one is mod of Z minus 2 less than or equal to 1. And writing x plus iy for Z, we get mod of x minus 2 plus iy less than or equal to 1, squaring on both sides. You will get x minus 2 square, whole square, plus y square less than or equal to 1. What is this? It is a circle with the center at C with the coordinates 2, 0. And it is the interior of that circle and radius 1. It is the interior of this circle and including the points on the circle. That is, it is the interior of the circle with the center at C with the coordinates 2, 0 and the radius 1, including the points on the circle, that is including the points on the circumference. Let's look at the diagram. That is the x-axis, y-axis, and that is your circle, and with the center C, and the coordinates are 2, 0 and the radius of the circle is 1. Agreed. Now let's get into the second one. The second one is Z into 1 plus I plus Z bar into 1 minus I less than or equal to 2. So again writing x plus iy for Z, we get x plus iy into 1 plus I plus z bar is x minus iy into 1 minus I less than or equal to 2. On simplification, you will get x minus y less than or equal to 1. It is same as y greater than or equal to x minus 1. And what is y greater than or equal to x minus 1? Y is equal to x minus 1 is a straight line. And y is greater than or equal to x minus 1 represents the region that lie above the line y is equal to x minus 1 and is equal to x minus y is equal to x minus 1 is also included. Therefore, including the points on this line, including on the point. All those, the region that lie above the line y is equal to x minus 1, including the points that lie on this line. So, and this line and the earlier circle will, let us say, they intersect at points A and B. So, how it is given? So, substitute y is equal to x minus 1 in the equation of this circle and solve, then you will get the values for x. So, x minus 2 whole square plus y square. For y we have written x is x minus 1. So, x minus 1 whole square is equal to 1. Solving, you will get 2x square minus 6x plus 4, and that is further will give you x square minus 3x plus 2. Factorization, x minus 2 into x minus 1, that will give you x is equal to 1 and x is equal to 2. And now, if you take x is equal to 1, y is equal to x minus 1 will give you 0, y is equal to 0. That means the point of intersection is 1 comma 0. And x is equal to 2, y is equal to x minus 1, substitute x equal to 2 in this, y is equal to 1. That means 2 comma 1 is the other point of intersection of the given line and the given straight line and the circle. So let A is equal to A with coordinates 1 comma 0 and B is equal to B with coordinates 2 comma 1. These are the points of intersection of the line with the circle. So that is the line, and above it means above the line means this is the common portion. This is the common portion. That is the S. That is the S. And they intersect at A and B. So what is S? What is S? The interior including the circle and the points that lie above the line, including the points on the line. And the region S is shown in the figure with a dotted lines. So this is the S. This is the dotted one. This is your S. So above the line and inside the circle, and points on the circle are included and the points on the line are all also included. So this is the S. And we are given a point P whose complex number, which is represented by a complex number 4i. So somewhere here, Z is equal to 4i. So you have to get the distance of Z to 4i. So the Z is in the S. Z is in S. Modulus of Z minus 4i you have to take, and for various values of Z belongs to S, then consider the minimum and maximum of all those distances. So the minimum is attained at Z1 and the maximum is attained at Z2, and we are given a relationship that 5 times of something. Agreed? And that is equal to alpha plus beta root 2, and to find alpha and beta and to find alpha plus beta. That is the question. Agreed. We continue in the next slide. That's what we have so far. And the circle equation is given here. And see, the center of the circle is given here. And the points of intersection of the line and the circle are A and B. The coordinates are also given here. Agreed. Now let P with fx 4i in the complex notation, that is equal to, the P is equal to 0 comma 4 in the Cartesian system, be the point on the imaginary axis somewhere here. So P is this one, P is equal to 0 comma 4. Now we consider the set of all modulus of Z minus 4i where Z belongs to S. So that means for various values of Z belongs to S, the distances, modulus of z minus 4i, the distances, there are infinitely many distances will be there. That will be the set of all distances between the P, 4i and the points of S. And and you have to find out the minimum, where the minimum is attained for this set and the maximum is attained at some point, and that point the minimum is attained at Z1, the maximum is attained at Z2, and then we answer the question. So let D be the point of intersection of the line PC and the circle. So PC and the circle, the line joining the P and the center of the circle, and the circle, the point of intersection is D. Let's find out what are the coordinates of D. So the equation of PC is P, we know P is 0, 4 and C is 2, 0, and use the 2-point formula for the straight line. Then you will get the equation of PC is y minus 4 is equal to 0 minus 4 by 2 minus 0 into x minus 0. And that will be equal to y is equal to 4 minus 2x. So this line is 4 minus 2x. Now take this line and this circle, the given circle, and substitute in that y is equal to 4 minus 2x and solve for x. Then you will get the coordinates of D. So the effort is to find the coordinates of D. So x minus 2 whole square plus y square is equal to 1 implies x minus 2 whole square plus y. For y we have substituted 4 minus 2x whole square is equal to 1. Solving, we get this, 5x square minus 20x plus 19 is equal to 0, a quadratic equation in x. And solving for x is equal to minus b plus or minus b square minus 4ac by 2a. The formula is applied and simplified. You will get 2 plus or minus 1 by root 5. So if you take x is equal to 2 plus 1 by root 5, then substitute here y is equal to 4 minus 2x, then you will get the value y is equal to minus 2 by 5. So 2 plus 1 by root 5 comma minus 2 by root 5 will lie in the fourth quadrant. And x is equal to 2 minus 1 by root 5, then y will be 2 by root 5. Then the point 2 minus 1 by root 5 comma 2 by root 5 will lie in the first quadrant. So we want D. D is in the first quadrant. Therefore D, the coordinates of D are given by 2 minus 1 by root 5 comma 2 by root 5. The other point will lie somewhere here, that is in the fourth quadrant. So we want this one. Why are we interested in this? So notice that the minimum of modulus of z minus 4i is attained at D belongs to S. Yes, D is on the circumference, D belongs to S. So the minimum is attained at D. So therefore, and it is given the minimum is attained at Z1 belongs to S. So Z1 must be equal to the complex number corresponding to D. So Z1 is equal to 2 minus 1 by root 5 plus 2 by root 5 I. Right. And modulus of Z1 square we have computed, that is 2 minus 1 by root 5 whole square plus 2 by root 5 whole square. Simplifying, we will get 5 minus 4 by root 5. So now we are on the lookout of the maximum of modulus of z minus 4i, and that is attained at Z2. Then you have to compute mod of Z2 square and then answer the question. So now S is here. Modulus of Z1 square is 5 minus 4 by root 5. We have already computed. And now notice that the maximum of z minus 4i, where z belongs to S, is attained at A or B according as PA greater than PB or PB greater than PA. So this is PA and this is PB. And in figure, it is looking like PA is greater than PB. That is the distance between P and A. The distance is greater than the distance between P and B. So at A, the maximum is attained, and Z2 will be the coordinates of A. But anyway, we will compute now what is PA. P is 0, 4, A is 1, 0. Use the distance formula. You will get under the square root of 17. And PB, the coordinates of P are 0, 4. For B, the coordinates are 2, 1. And use the distance formula. You will get root 13. So PA is greater than, PA is root 17 is greater than root 13. Therefore, the maximum is attained at A. So the maximum of modulus of Z minus 4i is attained at A with coordinates 1, 0 belongs to S. But it is given the modulus of Z minus 4i attains maximum at Z2 belongs to S. Therefore, Z2 is equal to the complex number corresponding to 1, 0, that is 1 only. So Z2 is equal to 1, mod Z2 square is equal to 1. But we are given 5 times of mod Z1 square plus mod Z2 square in brackets is equal to alpha plus beta times root 5. Required to find the value of alpha plus beta. So now substitute in this. This will imply 5 multiplied by mod Z1 square is 5 minus 4 by root 5. We have already computed in the last slide. Plus mod Z2 square is 1. Now when you is equal to alpha plus beta root 5. 5 plus 1, 6. 6 5s are 30 minus 5 by root 5 into 5, that is equal to 5 root 5. And you will get that is 30 minus 4 root 5, sorry. It is 4 root 5. 5 into 4 by root 5 will be 4 root 5. So 30 minus 4 root 5 is equal to alpha plus beta root 5. These are two surds. When two surds are equal, the corresponding terms are equal. So alpha is equal to 30 and beta is equal to minus 4. Required to find the value of alpha plus beta. Therefore, alpha plus beta is equal to 30, beta is minus 4, that is equal to 26. Thus, the answer to this question is alpha plus beta is 26. So, the answer is 26 is the numerical type. Therefore, that answer 26 is you have to write. That is the detailed discussion of the solution of the problem from the section quadratic equations and complex numbers, and the problem is related to complex numbers. I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.